Welcome back to the video for Chapter 7 of the midterm review. We're starting with problem 24. It says, a company makes two kinds of pizza, special and basic. The special has toppings of cheese, tomatoes, and vegetables. Basic has just cheese and tomatoes. The company sells at least 6 units a day of the special pizza and 4 units a day of the basic. The cost of the vegetables, including tomatoes, is $2 per unit for special and $1 per unit for basic. No more than $32 per day can be spent on vegetables. And the cheese used for special is $5 per unit, and the cheese used for the basic is $4 per unit. The company can spend no more than $100 per day on cheese. Okay. So we've got some limitations here. So as far as how much they want to sell, I'm going to say X is going to be my special pizza and Y is going to be my basic. And we're limited on, not limited, but they want to sell, they do sell at least 6 a day on X. So we know that's going to be at least 6 on the special. And then Y is going to be at least 4 a day, 4 units. Okay, so the cost, they don't want to spend, the cost here is made up of a couple of things, right? So, $32 a day can be spent no more than $32. So no more than 32 per day can be spent on vegetables, including tomatoes. Okay, so this is the vegetables restriction. Well, the special one has cheese, tomatoes, and vegetables. The other one just has tomatoes. So we basically, this is vegetables and tomatoes together. So the special pizza said, the special pizza is limited to 2x plus 1 unit of the basic. And then the cheese is limited to, or it's $5 for the cheese for the special, and then 4 for the basic, and that they don't want to spend more than $100. So it looks like these are our 4 limitations. So I'm going to make this smaller here. Let's go ahead and bring up our Desmos Graphing, and let's put these in. So X is going to be greater than or equal to 6. Y is going to be greater than or equal to 4. 2x plus y is going to be less than or equal to 32. And then 5x plus 4y is going to be less than or equal to 100. And I'm going to make this my main screen for just a moment so that we can see this really well together. And let's zoom out so we can really get a good picture here. So we want to cover where everything is all together, right? The darkest, which is going to be right in here. So that is one of our, I don't think I gave you graphing on this one, did I? No. So that's going to be one of our restrictions. It looks like it's a triangle here. So this point here, so 6 and 17.5. And then 6 and 4. And I'll show you my paper in a minute. I just want to make sure you can see this screen really well. 6 this one right here, 14 and 4. And then this one right here, 9 point. So it's actually 9.33, comma 13.33. So those four. So I'm going to show you here on the paper. So these are the 4 points. So within here is what we can make. So this is going to be 28 thirds and 40 thirds is this point here in fraction form. 6 and 4 and 14 and 4. So in this shaded area will be there, any units. Okay. Let's look at question number 25 and 26 are really just, I just gave you some basics so that you could put them into Desmos, find the shaded area. We're going to find our corner points, and then we're going to maximize this value. So this we're maximizing z equals 6x plus 2y. And actually, you have to just on the paper cross that out. It's really z is equal to 6x plus 2y. So let's go ahead and so x is going to be greater than or equal to 0. Y is going to be greater than or equal to 0. And then we have 2x plus 7y is less than or equal to 14. And then 2x plus 3y is less than or equal to 10. So I can zoom in. Here. So it looks like these are the corner points here. So 5, 0 is a corner point. One, 2, 3, 4, 5. Okay. And then 3.5 and 1 is a corner point. 0 and 2 is a corner point. And then 0, 0 is a corner point. Okay, so I'm going to make this small so that we can also see here. So there's my graph, here's my corner point. Okay, and here's my corner points. So I'm going to put these in. We're trying to maximize this function here. So 6 times 3.5 plus 2 times 1 is going to be 21 plus 2 is 23. And then 6 times 0 plus 2 times 2 is 4. And then 6 times 0 plus 2 times 0, that makes that one easy. So it looks like this is our solution. So when x is 5 and y is 0, the maximum of 30. That's not problem number 25 here. Oh, 25. And then let's look at problem number 26. Problem number 26. Okay. Here, this time we want to minimize our function. So x and y are both greater than or equal to 0. This time we have 8x plus 9y is greater than or equal to, so I gotta change my greater than or equal to 72. And this one is a greater than or equal to as well, greater than or equal to 72. 6 and 8. Okay, and we want to minimize the equation of w equals to 2x plus 10y. So down here, make sure that you change this. That was a typo on my end. So we're minimizing, this is minimize w equals 2x plus 10y is minimized. Okay, so let's graph this here. I'm going to make my graph a little bit bigger for now in Desmos just so we can see. And it looks like it's unbounded. So we've got 0 and 9 is a corner point. And then 12 and 0. So I'm going to just make this bigger so you can see. So we've got 12 and 9. So we've got 0 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have this here. And then here. And then this way. So it's unbounded because it's this entire shaded piece right here. And so we're going to minimize these. So this would be 2, 0 plus 10, 9. So that would be 90. And then this would be 2 times 12 plus 10 times 0. So that would be 24. So our minimum of 24 when x equals 12 and y is 0. 6. So catch me back for one of the other lesson helps.